Hi, my name is Tarun, and this is my Lab 5 for physics, which is based on friction. So, the introduction. The goal of my self made lab was to determine the coefficient of kinetic friction between an eraser which was pushed onto a tabletop. And some of the softwares which were used were the tracker software, which was utilized to analyze the eraser's motion by recording its position velocity as it slowed down, and then also a Go script for the computational model, which depicted the eraser's acceleration and compared the measured data to theoretical predictions. And the goal was to find the coefficient of kinetic friction by examining how quickly the eraser, which slid on the tabletop, came to rest. And then the result, I calculated that the coefficient of friction was 0.587. So some of the fundamental principles that were used during this lab were Newton's second law, which which says that the change in an object's momentum is directly related to the net force acting on it, which is also shown in the equation. And then the frictional force, which is a force that opposes motion between two surfaces. And the force of friction is equal to mu coefficient, like the coefficient of kinetic friction, and then times the normal force on the object. And then some of the other equations which were used were the velocity update formula and the distance update formula as well, which were derived from Newton's second law. So this was the actual experiment. Let me just play. And as you can see, a person just pushed the racer from one side of the whiteboard and then to the other, where the racer stopped due to friction and other external forces. And then the graph on the right depicts the position versus time. And as you can see, at first it depicts constant velocity, but then after that it starts to curve down due to acceleration. Some of the initial values that I found were the mass, which was 0.034 kilograms, and then the initial position, which was negative 8.22 times 10 to the negative 2 meters, and nothing in the x and y direction. And then the initial position was derived using the first two timestamps, the difference in its positions, and the difference in times of the timestamps. And that gave me the initial velocity of 3.023 meters per second in the x direction, and nothing in the y and z direction. So this is my computational model, and the first part just involved setting the initial values such as the mass, initial position, and initial velocity, and then the time as well. And then the frame rate was 1 over 60. And then I also imported the tracker data from the tracker software with the times and the positions at the respective times as well. Now the second part, so the code on the left just calculates the change in velocities. The change in positions leading to the velocities at each of the distinct timestamps. And then the second part on the right depicts the change in acceleration from the velocities derived from before. And then after that, I calculated the average acceleration, which summed up all of the accelerations over the timestamps and then just divided it by the total amount of timestamps. And then I found the friction force by multiplying the average acceleration found previously and then the mass of the eraser. And the coefficient of friction, kinetic friction, was just derived by dividing the acceleration, which we got previously, by g, which was 9.8. And this gave us the coefficient of kinetic friction. So this is the observed versus the computational on the left. As you can see, um, the red line depicts what actually happened, and the green is the simulation. And as again, at first it depicts constant velocity, but then after that, it curves down due to other forces acting on it and making so that there isn't constant velocity. So some of the possible sources of error were the point mass tracking. The point mass tracking did lead to inaccuracies as the definite center of mass of the object was not chosen every single time, which led to inconsistencies in the acceleration calculated. And then there were also other external forces present at the site of the experiment. Along with friction, there was also forces like drag, which had influence on the object, which slightly contributed to the deceleration experienced by the eraser as well. So now questions. My questions were, how would the friction force be affected if the normal force of the object would increase? So since the frictional force is proportional to the normal force and the coefficient of friction, the increase of the normal force would cause the magnitude of the frictional force to increase as well. And this is due to the fact that the increase in normal force is a result of the mass having a more rigid interaction with the surface it is sliding on, causing it to be slowed down even more due to the microscopic imperfection on the surface. And then how much frictional force would there be if the coefficient of friction was 0? There would be none present, as coefficient of friction is proportional to the force of friction. And a coefficient of 0 implies that there are no microscopic imperfections on the surface, which the object is in contact with, and there would be a force exerted on the object by the surface. Thank you for listening.